7th, this is a review of section 1.3 when we take a look at squares and square roots. So some of this might be a little bit of review from last year, but square roots is probably new. If you haven't heard of it from before now, no worries, it's pretty simple. Right now what we're going to do is we're going to take a look at all of these numbers 1 to 30. And all I want you to do is count how many factors each of these numbers have. So for example, 1 only has 1 factor. The number 2 has 2 factors. The number 3 has 2 factors. The number 4 has 3 factors. So you can go ahead and do that. And I want you to, oh, what's this? What do we got here? What do we got here? Let's see. Oh, sorry. Yeah, so this is just an example of showing you what the factors are for number 12. I have 1, 2, 3, 4, 6, and 12. Therefore, the number 12 has 6 factors, okay? And I want to take a look at them right now and see if you can pause the video and find if there's any pattern that you see with specific numbers, okay? After you're done pausing, you can take a look at the next slide right here. Numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. They all have something in common. They only have 2 factors. And we know that though they have to be prime numbers, yo. Again, this should be a review from last section. But what's interesting is the numbers 1, 4, 9, 16, and 25. You can see that they all have an odd number of factors, whereas every other number has an even amount. Now I want you to think about this. Why do you think this is? Just pause the video and take a second to think about it. After you've unpaused the video now, I can go over the answer. The answer is because they are called perfect squares. They have a very, very specific property about them. So for example, 1 times 1 will give you 1. 2 times 2 will give you 4. 3 times 3 will give you 9. 4 times 4 will give you 16. And 5 times 5 will give you 25. And so they all have an odd number of factors, as I just mentioned. So Mr. Mizrahi, his favorite football team is the 49ers. And 49 is actually a perfect square number. If you think about it, it's just 7 times 7, right? And so we would always say that 7 times 7 is the same thing as me saying 7 squared, which is why it is a perfect square number. If we were to draw it out, all of these squared numbers would make a perfect square. So for example, the number 9, something that has 9 units is a perfect square right here. And we take 3 units and multiply it with another 3 units to give us 9 units. Okay? Now, if we wanted to find the exact opposite of a square, if we wanted to find out, you know, what number can be multiplied by itself to give us 9, well, we're trying to find the root of the square, which is also known as the square root, right? So the square root of 9 is equal to 3. So when I'm looking at a squared number, I'm multiplying it by itself, 3 times 3, to give me my squared number, which is 9. But if I'm taking the square root, I'm taking a look at the number to find out which number multiplied by itself will give me this number. And the square root of 9 is 3. Just like the square root of 49 is 7. Okay, the square root of 16 is 4. Okay, so when we multiply a number by itself, we square the number. Really important. Right now what I want you to do is there are only, I think there's 10 squared numbers between numbers 1 and 100. See if you can list them in order. And 2 interesting perfect square facts is that if you just add a consecutive odd numbers, you will get perfect square numbers. So for example, 1 is 1, which is a perfect square number. 1 plus 3 is 4, which is a perfect square number. 1 plus 3 plus 5 is equal to 9, which is the next perfect square number, which is 3 times 3, and etc. Like if you take a look, you can just keep going. So that's really interesting. The second interesting fact is that squares always end in the digits 0, 1, 4, 5, 6, or 9. So as you can see right here, these are your first 12 perfect square numbers, and they all end in either 0, 1, 4, 5, 6, or 9. Okay, I think that should be it. So you should be working on your homework. This has been a review of section 1.3.